Okay, let's take a look at our last side for exponential functions. We have on what I call 9-3, exponential growth. We are going to have a lot of formulas in this section. So let's try to keep up with the formulas. I hope you have a formula sheet where you're writing these down, however. An exponential growth function has this form. Y equals A times 1 plus R to the 10th to the t power, where A must be greater than 0. Otherwise, everything would just be 0. Y represents the final amount. A represents the original amount. R represents the rate of growth expressed as a decimal. And T represents time. So let's go slowly. Here's a nice word problem. The original value of a painting is $1,400, and the value increases by 9% each year. Write an exponential growth function to model this situation, and then find the value of the painting in 25 years. You need the formula because you're not going to calculate it 1 year at a time. So you need a formula that you can calculate it for any number of years. You can use this for something like expense of a home, or the value of a house, the value of a car. Whether it's growth or decay, here comes your formula. Write the exponential growth function for this situation. All right, y equals A times 1 plus R to the t power. A is 1,400. R, your rate, increases 9% each year, 0.09 plus 1. So I have 1,400 times 1.09 to the t power. Step 2, I'm going to replace t with 25 years. That's my time. So I have 1.09 to the 25th power times 1,400. My painting will be worth $12,072.31 at the end of 25 years. This is a nice formula, but you do have to record the formula. So you need to record this right in the same place where you were recording your sequencing formulas and your quadratic formulas. We've had a lot of formulas this year. Compound interest. Here comes another formula. Compound interest. The interest earned or paid on both the principal and previously earned interest. Compound means that whatever you earn this year goes into your base amount, and so your principal increased. So next year's interest, you earn interest on your interest. That's why it's called compound, not simple. So here we go. A represents the balance after t years. P represents the principal or original amount. R represents the annual interest rate expressed as a decimal. N represents the number of times interest is compounded each year. You get a credit card and they compound your interest every month. Some credit cards compound your interest every day. So before you ever get a credit card, note to self, it's really expensive to have a credit card. I'm going to change that to yellow because that's bothering me that should have been yellow. Sorry. T represents time in years. N is the big deal number here. How often is it compounded? So let's get an example. Write a compound interest function to model the situation. Then find the balance after the given number of years. $18,000 invested at a rate of 4.5%, compounded annually for 6 years. A equals 18,000 times 1 plus 0.045 over 1 to the t power. I'm sorry, why is this little n in here? Sorry. Just have to clean up my work. Sorry about that. A equals 18,000. So now I had to do 1 plus 0.045 divided by 1 plus 1. Now, divided by 1, really? What is divided by 1? It means it's itself. So I didn't really have to divide anything. So it's really 1.045 to the t power. After 6 years, so I replace t with 6. Do my calculations, which I sure hope I'm using a calculator. 1.045 to the 6th power times 18,000. 23,440.68 cents. That will be my balance after 6 years. These are good formulas. So this is my compound interest formula. Please take a look at it. Make sure you understand what each letter meant. Know that you can substitute in and you can solve. Exponential decay. Exponential decay occurs when a quantity decreases by the same rate r in each time period t. An exponential decay function has this form. Y equals a times 1 minus r to the t power, where a is greater than 0. Y represents the final amount, A represents the original amount, R represents the rate of decay, which is going to be a decimal, and T represents time. Notice an important difference between exponential growth and decay. For growth, the amount in the parentheses will be greater than 1 because R is added to 1. For decay, the value inside the parentheses is going to be less than 1 because r is subtracted from 1. So right here, 1 minus r for decay. For growth, it was 1 plus r. The population of a town is decreasing at a rate of 1% per year. In 2000, the year 2000, there were 1,300 people. Let me get this. Write an exponential decay function to model this situation and find the population in 2008. Okay, let's start with step 1. Write the exponential decay function for this situation. Y equals a times 1 minus r, which is going to be a decimal, to the power of t, equals 1,300 times 1 minus 0.01 to the t power, equals 1,300 times 0.99 to the t power. Find the population in 2008. 1,300 times 0.99 to the 8th power. I went up 8 years. I went from the year 2000 to the year 2008. So my years were 8. I do my calculations, and it is approximately 1,200. The population in 2008 is approximately 1,200. Of course, I want you to go back and look at those formulas. My last formula is called half-life. The half-life of a substance is the time for 1/2 of the substance to decay into another substance. You're going to see this a lot in science, not just math. Well, math and science go together. We probably realize that by now. Half-life formula is written in this following form. A equals P times 0.5 to the T power. A represents the final amount, P the original amount, T represents, I see I have a spelling error, represents the number of half-lives in a given period. So let's take a look at what that means, our last slide. Fluorine-20 has a half-life of 11 seconds. Find the amount of fluorine-20 left from a 40-gram sample after 44 seconds. Okay, this seems like a lot of science to me, but let's go ahead and see how easy the formula can be. Find the number of half-lives in the given period. So to begin with, my number of half-lives. After 44 seconds, and I know a half-life is 11, 44 seconds divided by 11 seconds, 4. I have 4 half-lives. A, the original, or A equals P times 0.5 to the power of T. A equals 40, because I started with my beginning amount is 40 grams. 0.5 to the 4th power, 4 half-lives, 2.5. There are 2.5 grams of fluorine-20 remaining after 44 seconds. Complicated. That was a lot of formulas in a very short 11 minutes. Please go back and look this over. This is a lot of information that you actually will want to know. Good luck, and it's been wonderful doing videos.